Hi, this is Chong Kim. Welcome to Ruby Chess version 4, part 5. Okay, let's see where we left off. Okay. Okay, we have a passing test. Um, okay, so let's start writing a user interface for this so we can actually start playing with this. And, uh, and then we can see what once we have the chess program picking moves, we can actually see how good they are. Okay, so we're going to start off with um, I'm gonna take off the um, compilation, not the compilation, but the running of RSpec. So this way I can just work on the user interface. Okay, so let's edit chess.rb and require the file um, libchess.rb. We also want to, we're going to use Gosu. Okay, so let's see. We'll call it, we'll call it chess. And we inherit from Gosu window. And what we'll do is just to set this up, we'll create it and we'll show it. Okay, so initialize. So we have to create a window here. So we'll call super with the dimensions, width and height, and false for whether or not we want to use full screen. All right, so let's specify the width and height. Let's see. Width and height. Okay, so we'll set the width to be 600 and actually we'll make it a multiple of the cell. So I'll call CW C width, the cell width. So C width is going to be 100. So each cell is going to be 100 pixels wide. Okay, so the width is going to be a C width times 8. And the height is C width times 8. All right. Okay, so this should create a window. Let's just see this, and we'll set it up so that when we save the file, it will just run this. Okay, so we have a window here, and let's fix up the few problems, which is that the cursor is disappearing. We'll do that with forget what it's called. We can go into Gosu, so edit the gem which Gosu. And we know it's in reference, not lib. Okay, so we can take a look and see what it's called. Probably a better way to look at this, actually, okay. We're using tag bar to take a look. It should be located under Windows. Needs cursor, that's what it's called. Okay, so let's go back. Okay, so needs cursor. Okay. Oh, the question mark. And we'll set this to be true. So now when we do this, our cursor is still around. Okay, we also want to take a look at our keyboard input. So keyboard input would be, let's take a look. Keyboard. Button down. And that takes an ID. So we check the IDs for, we'll just say close if ID is equal to goes to keyboard Q. So if I press Q, then it should close the window. So now I press Q, and the window goes away, so everything's okay. All right. So let's build the screen. So we need to create. Okay, so it's under Draw. Okay, so let's draw a rectangle. Let's see. So we have draw line, draw quad. So it's draw quad. Okay. So if you want to see what that looks like, XY color, XY color. So you need 4 of these. Okay. All right. So I need XY and the color. And I need 4 of these for each of the corners. So for now, XY is going to be 0 and Y is 0. Okay, so draw quad from there to the C width. And then we want to do the other corner, which is Y plus C width. We keep the same color. You can have different colors for the gradient shading, but we're not using that. And we need to have X and Y plus C width. Okay, and for the color, we're going to specify okay, let's specify, let's see. Okay, so this is alpha, red, green, blue. So for the alpha, it would be OFF 255, which is the highest value. And I'll just, this will, if I want white, I want all of these would be OFF, but I want it to be a little bit off white. So I'll put it as CO. Okay, so let's see what this looks like. Okay, so that's okay. So now let's take a look at another color. So this would be, let's see, we'll call this light, and let's create a dark color. Okay, so the dark color will be, let's see, we'll lower these values to 4. Actually, let's say 3. Let's see what it looks like with 3. 3.0. All right, but I want a little tinge of green in there. So green is the middle color here. So I'm going to pump this up a little bit. So instead of 3, I'll say 6. See what it looks like. Oh, I forgot to. Okay, so let's see what the dark color looks like. Okay, that's a little bit too dark, so let's make this a little bit lighter. And you can make this lighter by just pumping these values up. So I'll make this into a 5 and this one into a 9. 5. Let's see. Okay, that's a little bit lighter, and that's pretty good. So let's make a grid of this. So let's see. 0 through 7. Okay. Actually, yeah, 0 through 7. Interesting. Okay, and I'll also have the 0 through 7. Okay. All right, so, and the color is going to alternate. So, so the color is going to be based on I plus j. So if that is even, divide by 2, not divide, mod 2 is 0. If it's even, then let's use the dark, actually light and then dark. Okay. And we have to calculate x and y. So x is going to be I times c width, and y is going to be j times c width. Okay, so let's see. Okay, perfect. This looks really good. And all we need are the pieces. So in order for us to have the pieces, we have to create a, let's create accessor for position. Okay, so that's a new position. Okay. This is interesting. This is getting an error because it doesn't know about E1, and the reason why is because in chess.rb, it doesn't know about chess helper. This was able to pass before because in the spec we included chess helper globally, so it knew about it. Okay, so now it doesn't complain. Okay. Okay, so that was something that should have been there, but because of the R spec, we have a lot more confidence in chess.rb, the lib chess.rb. I'm actually kind of thinking maybe I should rename this to game.rb, but we'll just leave it. All right, so let's draw the pieces. So first we need a font, since we're getting it from the font. Okay, so for the font, go to font default name, and we need to create a font. So go to font new, and actually I think it's I think it's under default font name. Okay, so I have to go take a look at Gosu now. All right, and look under, see. So it is default font name, but what does the constructor look like for the font? Okay, so color, there's font, and let's just go there. So initialize, it's right here. Okay, so initialize a window font name height. Okay. Window, that would be self, font name, and height. We'll make it the same as CWidth. Okay. Okay, and so when it draws, this draws the background background cell, and then we can just put the font right here. So font draw. Okay, so let's see what font draw is. Font, there's draw. Okay, so it's the text, X, Y, Z, and we'll leave the color alone. Okay, so let's just focus on font X, Y, Z. Those are the required parameters. All right, so draw. I'll just put an X for now. X, Y, Z will have it as 1. All right, so let's see. Okay, so it looks okay. We actually want it centered, so there's a function to find out how big this this will be, and that is let's see, let's look here. It's called text width. So if you give it a text, then we can see how big it is. So let's use that. So so what we can do to calculate the position is we have the cell width, and if we divide it by 2, that's the center, and we want to subtract the cell width, not the cell width, the font width, the font text width of X, and we want to divide that by 2. So we can actually do it this way. Factor out the divide by 2, and that would be the X position. So we can try this out. So let's take this and just put it right in here, and let's see if this centers it. Okay, so this looks better at centered. All right, so actually let's call it CX just to make this a little clearer. All right. Okay, it's colored white. Do we want it colored white? Let's see what other parameters there are. For draw. Okay, so if you want to do color, then we have to include X and Y factor. Okay, so let's do the color. So 1, 1, and let's say it goes to color black. Okay, all right, so that looks, okay, that looks okay. Okay, so let's actually draw the pieces. So there's a set. Okay, so we can create, let's go in here and create the, let's see, pieces. And this will just be a map. So if it's a capital R, it's going to be, okay. And again, I'm doing, I'm on a Mac, so I'm doing Command Option T to bring this up. And I could type chess in here, and this is how I was able to get the chess pieces. Okay, so see, it's a white rook, so white rook. Okay, so okay, rook, knight, bishop, queen, king, pawn. Okay, and let me just set these up. Okay, and then we also need rook, knight, bishop, queen, king, pawn, and set those up as well. Okay, actually I have it reversed. Okay, all right, so the knight is the white knight. The bishop oops, queen. See, look for the queen. There it is. We have the king. It's the white king right there. Pawn. Okay, now we do the black pieces. So black rook. Black knight. Black bishop. Black queen. Black king and black pawn. All right. All right. So I could space these out. Okay, so let's see if, okay, so now we have this mapping, and what we'll do is we'll look it up. Actually, we need to convert it into an index. So it's, since we're outside of the libchess, we don't want to know the guts of it. We don't want to do the formula here where we're saying things like the index is equal to I times I plus j, whatever, and so on, because that that's too much knowledge that you need to know about it. So instead, um, I'm going to create a function which will turn it. Actually, let's take a look at chesslib, see if there's something that already exists. Okay, so the um, these there are some functions, but um, what I actually want is given a pair. So for example, if I have something like um, the row and column, then I want it to be like turn that into an index. So that's what I'm missing. Um, okay. So let's see the x and y actually. Uh, so I'll just create one for an array. So if I have an array, I'll have a 2idx, and okay, so this will give us the formula. So if it's a 0, this one we should really um, create a test for this. So let's create a test. Um, okay, we need to bring this up. Okay, so let's go to the spec. Yeah, because we don't want to have this wrong, and we would have to try to debug this for a long time. Okay, so for an array, 2idx. Okay, so let's think about this. So the first one would be 0, 0, 2idx, and we expect see, we expect that to be equal to A8. See, is that right? Yeah. Okay. So the reason why we want 0, 0 to be A8 is because that's how our graphics are set up. The 0, 0 corners is going to be in the upper left-hand corner, like right over here, and then it gets bigger as you go down and bigger as you go to the right. So so that square would be the A8 square, and if you increase it by 1, so we want this to be the x. So if I increase it by 1, and that should be uh, B8. Okay, and if I increase it by 1 over here, then that should be A7. Okay, so all right, so let's create it. Okay, so then you have this would be the x part. So we'll just leave it alone, and then actually, and okay, so we have a little bit of a border there, so it's a border of 1. And actually, we can just take a look at how this is written. So 8 minus the second argument would be self 1. Okay, so plus 1 times 10. Okay. All right. So let's see if this works. Okay, so this didn't work. Okay. Oh. Okay, so it's probably this. Okay. All right. I was looking here, but I realized that for the y part, it's flipped because 1 starts at the bottom. The low number starts at the bottom, but in this case, the low number starts at the top. So it's a good thing that we wrote the test. All right, so the test is passing. So now let's go back to our program here, and we can actually convert it now. So the index is okay. So that's our index. So we can find the piece for it. So position board of IDX, and that's our piece. Actually, yeah, so that's our piece. And we'll look it up. So we have pieces. We'll look up the piece, and by default, it'll just become an empty string. And actually, let's just make this explicit. The text, I'll just use txt in case like there's a method called text. Actually, I'll just use stir. Okay, just to be consistent with everything. So pieces based on a piece default to an empty string, and we take the cx and replace the x with the string, and we put the string right here. Okay, so let's see what it looks like. Actually, we need to change it now. Okay. Ooh, not so good. Interesting that the pawn happened to, oh, actually, oh, I see. The x, it's the x that's not correct. All right, so let's just fix the x. The cy, okay, so the y part, the c, okay, so for the x part, we're using cx, and cx is calculated here. And we forgot to add, well, actually, we can just add x to this, and that should take care of it. Okay, so this looks like a very nice board. And what we need to do is just be able to move these pieces. All right, and that should be buttoned down again. So let's see. All right, so I'm going to create from and to. Okay, so we have a button down, and if it's a mouse, ms, left, if a mouse button is pressed down, then we're going to set the from. And we can calculate this by, actually, we need to say ID. Okay, so we need to calculate based on where they clicked on it. And so there's mouse x, we convert that to an integer, and we divide it by the c width. Okay. Okay, and I'm going to convert this, so I'm going to make this into an array. So we have the x position and the mouse y 2i c width. Okay, so this gives the y position, and I'm going to say 2 index. So this will give us the index position for the from, and on the mouse up, button up. Okay, and if ID is equal to goes to left, then actually it's going to be more complicated, so we'll just put to a block here. Let's just print this out for now. Print the from. Okay, so if I move, I press my mouse down, I move here, and I let go, I get 85. Okay, so let's see if that's correct. So I'm going to convert that to 2 square so we can see it. That should say E2. E2, perfect. Okay, so now we need to get the, let's see, actually, I'll create a function here called get index, and that'll do exactly this. Oh, and I need to convert this to IDX. Okay, so, all right. This makes it a little bit simpler because we need to do this again. Right, so now when I click let go over here, I should see E2 and E4. Great. Okay. All right, so now we have the from and to, and we can actually make the move. So we can set the position and tell it to move from to. And to is equal to get index. Okay. And we don't need to print these out again. So now when we move it, okay, so we're able to move the pieces. Okay. But we're able to move pieces just anywhere. Okay, so we should fix that problem. Okay, so let's take a look at move. Well, one of the probably the best way to do this is just with position we have possible moves. And we can just see if that's included. Include from to. And we'll say if that move that we just made is included in the possible moves, then we'll make it. Okay, so let's see if that's okay. So that worked. This worked. So now let's see if I try to move this. I'm trying to move this to an illegal position and it won't let me. So this is a quick way of doing this. All right. So I'm going to quit out. So that's why possible moves is really important. Okay. So so now that we have this, we need the computer to move. So in order for the computer to move, we need best move. Okay. So I know I've been talking about the A-star algorithm and compared to the minimax, and there's a lot of advantages to thinking in terms of the A-star, but the problem with the A-star algorithm is that it's not meant for games like chess. It's meant for something that is not adversarial, because with minimax there's actually two states. You have a position where you don't actually have a tree. Interesting. Okay. I'm pressing tab and it's bringing me all over the place. Okay, let me see. All right, now I'm free. Okay, so if I have a starting node position and I have children, so I could have like many children like this. Then actually this is probably not the best way to draw it, because for a tree maybe this way is better. So okay, this is probably better. So from one position you could have many children, and but in this case you're trying to do a max here, trying to maximize. Actually, let me just say plus, and this is minus. Make it look like dashes. So maybe this looks a little bit better. All right. So okay, so you have one position, and actually this is a lot more, because when you're playing chess, especially in the beginning, you're gonna have probably a whole like 10 different possible starting positions. Uh, see, actually 20. There's you have 8 pawns. Each of the pawns can move, so that's 8. But they can move in 2 different ways: one move or two, 1 square or 2 squares up. So that's 16 just for the pawns, and then you have the knight. So that's about 18. 18, no, 20. So you have 20 of these children. That's the starting point, and then from there it can grow. So this grows really big, really fast. Um, so with minimax, you're trying to maximize and then minimize and then maximize. You alternate. So and then this one you try to maximize, and this is going to have many children like this. Okay, so that works fine for minimax, but for the A star isn't really meant for this. But the thing I like about A star, well, before I say that, with A star algorithm, it's instead of trying to minimize and maximize, it's always trying to maximize. So it's assuming that for each step of the way you have the same goal. So if this was a graph and you want to make your way to a certain spot, then uh, then each of these nodes are actually trying to do the same thing. But with chess, each of these nodes, every other one is trying to do something different. So that makes it um, inappropriate to use the A star algorithm, but you can modify it, because the thing I like about the A star algorithm is that it's best first. All right, which means that you evaluate each of these positions locally. You don't go deep, uh, and then you find out which one looks the best, and then you start looking deeply based on whichever is best at the moment. So we'll start off with the minimax algorithm, and then slowly uh, modify it so it has some of the features of the A star algorithm. So okay, so we have something good here right now, and uh, the other thing too that we did was uh, we made this program a lot faster than the version that we had before, and the previous version was really slow. I think it took about 30 seconds to run through the whole suite of the PGN file. And this one, it's actually, it does in less than half a second. Um, so uh, so we should see what the minimax is going to behave like. Okay, so um, so I think we should, since we have the interface, we can go back to the lib and we can add some stuff to this. Um, okay, um, we should start writing the minimax. So let's go into the spec and uh, prepare to write the minimax. All right, so um, okay, because I'm doing something else now, like writing the engine. I could write this into another uh, class, but right now this is pretty small as it is. It's about 200 lines, so I'm not gonna. Actually, the spec is 200 lines, and the code is about 300. Mm. So I'll just keep it all in here for now. Yeah, we could always move it later. Okay, so let's begin. All right. So first thing we need to do is be able to evaluate uh, whether or not the position has ended. So actually not def. Actually not describe either. It's context. Um, what we need is checkmate, and we'll set up a checkmate position, which is we'll set up a position where it's not a checkmate, so we'll just have a new position. and we say checkmate, and that should be false. And now let's set up a checkmate position. So we have a king on e1, a queen right on top on black queen right on top on e2, and a king, a black king on e3. And we say checkmate, and that should return true. Okay, we gotta change this now. All right, so let's write checkmate. Checkmate should be fairly simple because we have a lot of the methods already created. So you're in check. Actually, this should pass, but this is not correct. Okay, so we need another test. The test is that the king is on e8. It's too far away. It's not protected. So this actually this pass, but the test is wrong. It should be false. Okay, so it has to be in check, and you have the possible moves. Is empty. All right, so now we have checkmate. We also want to do stalemate. We almost don't need tests for these because the code is so simple because it's based on in check and possible moves. So, but let's just make this. Let's just formalize this. So stalemate. That's false. I'll change the queen into a pawn, and okay, so and change checkmate to stalemate. Okay, so we write stalemate. So it's not in check, and possible moves is empty. All right, and there's another situation for a draw, and I'm not going to write the test for that. And because it's just going to say it's either a stalemate or you're not in check. Actually, if it's not checkmate and the full move count, actually the half move count, because the whole point of the half move count is to check for a draw. So it's greater than or equal to 100. So that would be a draw. Okay. Well, I could write a test for it, but yeah. All right. So now we know the end position, so we can start writing the minimax. All right. So let's take a look at the minimax. All right. So let's actually I could just copy the checkmate. All right. So I have a checkmate situation, and I'll call the minimax on this, and okay. So in this situation, what I want this to be is some very high number, and I'll just, for now, I'll just base it off of, just say 100. Okay, and then I just need to change the colors here. And it's black's turn. And that'll be equal to negative 100. Okay, I'm putting parentheses here because with this minus here and the way this is laid out, it thinks that this is a subtraction instead of negative. So, all right. Okay, and should also have stalemate. So in a stalemate situation, that's going to be equal to 0. Let's say minimax. Okay, these are all the base cases. Okay, let's write minimax. And if checkmate, then we're going to return, if it's white, it's going to be 100, otherwise negative 100. Okay. All right, and for a draw, okay, so we have the base cases set up. So let's see. All right, so we want to be able to also pick out a win and one. So we take the same situation here, except we're going to move the queen. See, it's going to be black's turn, so it's going to be one move behind. So turn is black, and the queen is going to give checkmate. So I'm going to put this on d3. So this should also give a win. So I'm going to say I'm going to give a little bit of a penalty here of the depth. So I'll just say 99. And also, since I'm doing that, I might as well do it for switch the colors here. And I'll say the turn is white. And let's see, it's black's turn. Actually, I think I have this backwards. Yeah, I do have this backwards because if what I want is positive for a good white position. So white is being checkmated, so it's actually supposed to be the negative. So this should really be negative 100. And this is positive 100. And 0, so for white being checkmated should be negative. Okay. All right, so let's go back here and fix this up. So if it's white checkmated, then it's negative 100, otherwise it's 100. All right, so so now, since we have the base case taken care of, we need to handle the recursive case. So we can start off with the possible moves, and so we have the move, and we can duplicate the position and make the move, make the move, and we can say minimax on that and find the max. Okay, so this is gonna take forever. Okay, so all right. The reason why is because a lot of these. Oh, let's just put a depth on this. Okay, so I'm going to have to pass in a depth and default it to 1. and see, okay, all right, and we'll just return 0 if hmm, hmm, actually we're not going to return 0. Um, we'll return nil. Okay. Uh, else if depth is greater than, let's say, 2, then return nil. Okay. So, all right, so let's take a look and fix them with nil. So what we really need to do when we do a max is we need to compact this to get rid of all the nils. All right, so expected -99 but got 0. That's because we're using max. So we have to actually send it either a max or a min, but based on whose turn it is. So if it's white's turn, we want to do a max, otherwise we want to do a min. Okay, so let's take a look. All right, so this is close, and the reason why this failed is because we didn't give a penalty. Uh, so we need to do penalty based on a depth. So if you're white, then you want, okay, so if you're white, you're trying to maximize. So for each depth that you go into, we're going to subtract the depth. Otherwise, we're going to add the depth for black. So this will be a penalty. This is going in the opposite direction. Okay. Undefined method plus for nil class. Nil. Let's see who's okay. Minimax. Okay. Well, for now, let's just return a 0 to get rid of any kind of nil problems. Okay, so this passed, but there are situations where let's find out. Let's see, because I don't want to include anything that's greater than if the depth is greater than 2, then return nil, and then this whole thing would be nil. And okay, I see. So let's see, values. I'll just call this values. Possible moves, you map it, you compact it. Okay, so now we only want to do this if values um, is not empty. So okay, so this looks like it works. All right, so otherwise it'll return nil. Um, okay, so actually with minimax, we should really, actually I have to think about this now because the way minimax works is that it sort of, it, actually I think I will just return 0 because it should always return a number. Um, so I'll just have it return a 0. Okay, so we have minimax set up, and it was able to find the winning move. Okay, let's see. So with this, actually, let's see what happens. How long it would take if I change this depth. This is only looking at one ply. So I'll just increase this to 3 and see if this, let's see how long this takes. It takes a little bit of time. Still, okay, 4 seconds. It's not bad. Um, uh, But this is looking at it in, complete. This is looking at it like uh, see, this is 2 levels, 2 plies. This is looking down 2 plies as a full tree, and so um, it's 4 seconds. It's not bad for 2 plies. So okay, so let's write the best move. Okay, and we'll play with this. Okay. All right, so you start off with the possible moves. We either want to have, if you're white, you want to do max buy, otherwise min buy. Okay, so what you do is you make the move and you do a minimax on it. Okay, so this will return the best move. Actually, we didn't write any tests for this. Okay, so let's write a test for this. There are probably ways that we can speed things up a little bit. So because the test is taking a few seconds, we can actually um, tweak it to see if we can make it go faster. It'll help our program. All right, so best move. Let's do the best move. So I'm just going to write a simple test for the best move, which is if it's a mate in 1. Let's see which one. This is a mate in 1 position here. And I'm going to say best move, and that should be the d3 to the e2 squared, because that would be checkmate. So let's say interesting. So it didn't. All right, I'm gonna change this back to a 2 just to speed things up a little bit. Okay, so expected but got that. It's black's turn, so it's trying to minimize. Let's see where that is actually going. So see, we could just convert like okay, I'm just gonna map to square on it so I can read this a little bit better. B1. Oh, that's really interesting because that is the alternative winning move. So that's actually correct. There are actually 2 winning moves. In this situation, the queen, there's 2 checkmates that the queen can do, and that's one of them. The queen going to B1. So this is actually correct. It found an alternate solution, which is pretty funny. but so it worked. Okay, um, so I'm going to put a bishop on b2, so this way we'll get rid of that possibility. So I'm going to put a bishop on b1, so this way the queen can't go to b1. So now it should equal, let's see, it should go to the e2 square. So there it is, it's the e2 square. Okay, great. So we can get rid of this. All right, so we have best move. So now we have an engine using the minimax. But well, let's see how this goes, and then um, let's see how this plays. We'll see. Oh, we don't have. I see. What I want to do. Okay, this is where it was missing. Is that if it's not a checkmate or a draw, then we want to actually evaluate the position. So evaluate. And for the evaluate, we're just gonna have a score. I'm gonna set it equal to 0 in the beginning, and then we're gonna start adding stuff. So we're gonna add the board, count how many rooks there are, and multiply that by the value. It's 5. Okay. Actually, let's do it this way. Knight is worth 3. Bishop is worth 3. Then we have the, we're going to skip the king, and the queen is going to be worth 9. And the pawn is just worth 1. Okay, and then we just do the same thing for black. So we just change all of this to minus and convert these to lowercase letters. Okay. All right. So let's see. Okay. So far so good. All right. So, but we're going to add. So this is the basics of the minimax and for the best move, and now we can actually use it in our game to um, see how good it is. And we're going to find that it's going to be lacking, and it's going to be very slow. And then we're going to try to optimize it so then it can be a little bit faster and more efficient in the way that it thinks. Instead of covering every single possibility, we'll try to see if we can prune it down a little bit so that the calculation will be focused on the important things. Okay, so this is the end of this session, and the next session you can see that we have everything in place where we can actually do some strategizing. So see you next time.